AC is nothing but it is the alternating component. Okay, component that is important. Here I will take a reference time t. With respect to this time, the whatever current or voltage, if it is changing its magnitude as well as its direction with respect to the time, then that quantity itself is called as the alternating component. This alternating component is having both magnitude as well as the direction. Then this quantity itself is called as the vector quantity. Whatever I am writing in the screen is visible now? Anyone reply?
Yes, sir.
Thank you. Okay, here the generation of the sinusoidal voltage. What I am going to consider here, there will be a N pole, there will be a S pole. Okay, you might be know about the Faraday's laws. Okay, there will be a first law, then there will be a second law. First law states that whenever the flux linking with respect to the conductor changes, then which will causes the induced EMF. Okay, that is the what? First law. Second law is that the magnitude of induced EMF is itself is the rate of change of flux linking with respect to the conductor. It means that whenever a conductor is placed in the magnetic field, the relative motion between the magnetic field or the conductor will causes the induced EMF. That is what the generation of the sinusoidal voltage. But the conductor is rotating in 360-degree rotation. That is from 0 to 90, then 180, then 270, then 360. Okay, along with respect to that rotation, the EMF generation is taking place because the conductor will cut the magnetic flux. These are what? Magnetic lines of forces. Based on that, the EMF induced will be taking place according to that of 0 degree, 90 degree, then 270, 180. According to that operation, the whatever the EMF which it is to be induced in the conductor will be changes. That is according to the Faraday's law of electromagnetic induction. This is with respect to the what? The generation of the sinusoidal voltage. The sinusoidal voltage is nothing but the amount of magnitude of the voltage which is to be changed with respect to the time. Okay, here what happening with respect to the, if there is no flux linked with respect to the conductor, amount of the voltage which is to be induced will be 0. If it is 90 degree, amount of voltage which is to be induced will be maximum. Okay, if it is 180, the flux linking with respect to the conductor will be 0, then voltage will become 0. Then with respect to the 270, which is negative, then which is also be maximum. Okay, then with respect to the 360, the flux linkage will be 0, then magnitude of the voltage which is induced will be 0. This is what which it is called as the sinusoidal voltage generation because of the conductor rotation which is to be happening between N pole and the S pole. Okay, the conductor is rotating along the axis. With respect to that, what is the amount of flux which it is linked with respect to that of conductor will causes the induced EMF. That induced EMF will be alternating in nature, which is changing its magnitude as well as the direction with respect to the time corresponds to that of the direction of the rotation of the conductor. That itself will causes the sinusoidal waveform through the conductor, which will causes the EMF generation. This is what the meaning of the generation of the voltage which is to be caused because of the change in voltage which is to be caused by the conductor. How you can represent that with respect to the equation? Okay, that is E is proportional to V into sin phi. V is the velocity of the conductor which is to be caused. But the constant is what? Flux is constant, flux density, length of conductor is constant. So that this proportionality constant, that is indication will be represented by B into L. B is the flux density, L is the length of the conductor, V is the velocity of the conductor. Whatever the variation which to be happened will be taken into a sine of theta. Okay, that is the angular displacement which is to be happened with respect to that of conductor. That theta will be taken in terms of omega t. Omega is the angular displacement. So E is equal to Bm into sine omega t. By replacing this by the omega, BLV will be represented by Em. Okay, so that E is equal to BLV into sine of omega t. This is the what? The equation which is to be used to represent the sinusoidal voltage which is to be generated in the conductor which it is placed in the magnetic field. Okay, the whatever the length of conductor which it is rotating in the magnetic field will be the length. Okay, that is the L. B is the what? The flux density. Whatever the magnetic field which is to be caused for the unit area, that is pi by A, will be represented by the what? B, that is the flux density. Magnetic flux per unit area, that is represented in terms of Weber per meter square. V is what? The velocity of the conductor, because this conductor is rotating at some speed. Okay, that can be represented by the meter per second. Em is the maximum EMF which is to be induced in the conductor. Okay, this will be caused because of the flux linkage with respect to the conductor. Okay, this is with respect to the what? The generation of the EMF. Okay, this is also asked once. Okay, you can concentrate. Okay, the generation of the AC voltage, that is the sinusoidal voltage. Then frequency of the generated voltage. Yes, already I told AC component is alternating in nature, which is changing its magnitude as well as the direction with respect to the time. Obviously, there will be a positive half cycle, there will be a negative half cycle. Yes, if it is completing one positive half cycle, okay, and one negative half cycle, this itself is called as the time period. Then what is frequency? Number of oscillations per second is called as frequency. The another is also be called as the reciprocal of time period. That's also be called as a frequency. The whatever the cycles which are to be get induced by the EMF per second in the conductor, that itself is called as frequency. Number of cycles produced per second is also be called as a frequency of the generated voltage. Normally we can represent it in the equation F is equal to 1 divided by T. Reciprocal of time period is also be called as frequency, which it is measured in terms of hertz. H-E-R-T-Z. Okay, that is the what? Unit of frequency. Okay, here one question paper they have asked the definition of the frequency of the generated voltage for 4 marks. You can concentrate on that. Only don't write only the definition. Okay, write the expression and its unit along with definition. Okay, then you can get the marks, because definition 2 marks, unit 1 marks, expression 1 marks. Like that, this splitting will be taking place. Okay, among these 3 definitions, you can write any one. If I written 2, it's well and good. Got my point? Is my audio is clear now? Anyone reply?
Yes.
Thank you. Then some other definition related to that of alternating quantity, that is the AC component. One is instantaneous value. Okay, what is the meaning of instantaneous value? Whichever quantity which it is changing its magnitude as well as the direction with respect to the time is called as AC component. With respect to that AC component, the value at any instant of alternating quantity is itself is called as instantaneous value. That might be with respect to the voltage, that might be with respect to the current. Okay, the value of EMF induced in the conductor at any instant, that itself is called as instantaneous value. That can be represented for the voltage equation E is equal to BLV into sin theta, or E is equal to EM into sin omega T. Okay, this is also be what? Instantaneous voltage equation. Some textbooks they can use V into Vm into sin omega T. That's also be correct. Then I is equal to BLV into sin omega T. This is also be instantaneous equation. That I is also be represented by I is equal to Im into sin of omega T. Okay, what is this I? Small I, instantaneous current. Small v, instantaneous voltage. Then Em is maximum voltage, Im is maximum current. What is this omega? Angular displacement. T is the time at a particular instant. Okay, this is what the instantaneous value. This definition you can remember. Okay, this definition will also be asked. Then what is the maximum value, peak value, and amplitude? Okay, I will take the sinusoidal waveform. Okay, one of the positive half cycle. The maximum value will be occurred at 90 degree. Okay, with respect to the half of the waveform, this peak value is itself is called as the maximum value, peak value, or the amplitude value. The maximum value of the alternating quantity with respect to the voltage or the current, either for the positive half cycle or the either for the negative half cycle, is itself is called as maximum value, peak value, or amplitude. That can be represented with respect to that of Em for the voltage, Im for the current. E is equal to Em into sin of omega t, I is equal to Im into sin of omega t. Em and Im are called as maximum values. Got my point? Next. Okay, I will give at the end. Okay, if you are having any doubt, then you can ask. Okay, intermediate, kindly don't unmute by yourself, don't speak, which will create the disturbance for me as well as the recording. Second thing is that effective value or the RMS value of the alternating current or the voltage. Okay, it means that the root mean square value, because the alternating quantity is having both magnitude as well as the direction. With respect to that, we are going to define the effective value and the average value. Okay, the next topic is there for the average value. The effective value or the RMS value of the current is itself is called as the root mean square value, which to be happened with respect to that of same amount of heat to be get produced in the electrical circuit. That quantity is called as RMS value. Okay, for this what I am going to consider, one circuit I will consider. Okay, what I will do here, one element which is having a some resistance or which it is get connected to DC power supply. DC power supply, which will offer say closed circuit, will cause a current I to flow through it. Okay, whenever I am providing a DC power supply, with respect to that, according to the Joule's law, which it is producing the heat I square R for the particular time. Whenever you are applying a DC power supply, then which is producing a particular amount of the heat, if you are going to replace this source of EMF by the AC power supply, okay, whenever you are applied the AC power supply, if the amount of heat which it is produced by the DC is equal to that of amount of heat which it is produced by the AC, then whatever the magnitude of the current which is to be flowing in the network is itself is called as RMS value or the effective value. Got my point? That will be defined here. Okay, here the effective value or the RMS value of the alternating current is equal to that of the direct current produces same amount of heat produced by the alternating current when it is passed through the same resistance value for the same amount of time. Why you people are creating disturbance? I am not getting. Kindly don't create disturbance. Some people are there for the listening purpose. For them also you are creating a problem. Okay, this is with respect to the what? The RMS value of the current. Okay, this definition you concentrate. This is most important. Note it down in your notes. RMS value is definition is most important for the examination point of view. Then how you can represent, okay, root mean square. Amount of heat produced is what? I square R into T for the time as per the Joule's law. Okay, we have taken that into a effective values by the root mean square value. Okay, mean value is nothing but what? For the instant I1 square, I2 square, In square divided by N. I will get mean value, isn't it? Then what I need to do? I want root mean square value. So that I am taking the square root of I1 square plus I2 square plus In square divided by N will give the root mean square value for the current. Similar to that of voltages also. E1 square, E2 square plus En square for n number of instant. Then if I taken that square root value, I will get the RMS value. Okay, these are the what? The equation to be used to make your explanation for the definition point of view. Remember this, don't forget at all. Then derivation, what is the value? How you will going to get the RMS value of the voltage? Okay, here the derivation is also be most important, which is to be asked in the examination multiple time. Okay, that is the RMS value of the sinusoidal varying alternating component. You can derive with respect to the current, you can derive with respect to the voltage. It is of your wish, no restriction. But I have considered with respect to the current point of view, what I have considered the equation of the alternating current, which to be represented for the sinusoidal waveform. That is I is equal to Im into sine of omega t. But I am replacing omega t by theta. So that I is equal to Im into sine theta. Okay, this is what? The sinusoidal varying waveform, isn't it? Theta is what? Theta is equal to omega t. Okay, but I want the effective value. It means that root mean square value I want. So that the effective value of the alternating quantity is given by I square equal to 1 divided by 2 pi. Whenever you are going to make the evaluation of RMS value, you have to take complete positive half cycle and negative half cycle together. Okay, then this is what? The time period. This is T. This time period is how much value? 2 pi. Duration what which is to be defined. So that I square is equal to 1 divided by 2 pi. Okay, what's the duration? 0 to 2 pi. Integration of 0 to 2 pi I square into d theta. Integration value. I square is what? Instantaneous current square you have to take. I square m into d theta. But integration of sine square theta is not possible to integrate because I want in terms of sine or in terms of cos. Then only I can do with respect to the integration. So that the sine square theta is equal to what? 1 minus cos 2 theta divided by 2 with respect to the d theta. Then I square m I am taking out. I square m divided by 2 pi 0 to 2 pi 1 minus cos 2 theta divided by 2 into d theta. Okay, whenever you are integrating this one, integration of 1 is what? Theta. Integration of cos 2 theta is what? Sin 2 theta divided by 2. But 1 by 2 is the constant. I am taking that out. 2 into 2 is what? 4. I square, Im square divided by 4 pi theta minus sin 2 theta divided by 2. Okay, this is the maximum value. This is the minimum value. I need to replace. Okay, that is 2 pi minus 0 minus of. That is 2 theta to replace. Okay, that will become into 4 pi. Okay, not the 2 pi. This is 4 pi minus 0 because sine 0 is what? 0. Okay, so that I am replacing with respect to that value. Then what happens? 2 pi. Then with respect to this value will be taken into a count of the evaluation. Then the sine of 4 pi is also be equal to 0. Okay, then these two will become 0. This is also be 0. This is also be 0. Only it is having a multiplication of 2 pi. Okay, so that I will get 2 pi divided by 4 pi into Im square. So that I square equal to Im square divided by 2. Im square divided by 2. Then what I want? Root means square I want. So that I will take square root of this, which implies that I is equal to square root of Im square divided by 2. That is Im square is what? Im divided by root 2, which is equal to 0.707 into Im. That is the RMS value of the current is equal to 0.707 into Im. Okay, this derivation is also be important for the examination point of view. Concentrate on this also, don't neglect. Is this clear now?
Yes, sir.
Okay, practice, go through the notes. Okay, already you have studied, but you concentrate. Don't neglect. Okay, this will be asked for minimum 6 marks. If the derivation is asked, definition and derivation is asked, maximum is 8 marks. Is this clear now?
Yes, sir.
Okay. Is my audio is clear?
Yes, sir.
Thank you. Then the average value of the alternating quantity. Here also what I will consider? I will consider a circuit which is having a resistance R. Okay, DC source first I am providing. Okay, this is get connected to a resistance. Okay, this resistance is R. Okay, which will cause a current to flow I.
Yes, sir.
Okay, I need to define the average value of the alternating current. Okay, whenever you are providing the DC power supply to that of a circuit, it should provide the same amount of the transfer of the charges. When you are replacing, this is with respect to the AC power supply. Okay, means the amount of charge which is to be transferred by the DC power supply as well as the AC power supply should be same. Then with respect to that, what is the current which it is flowing in the circuit is itself is called as average alternating quantity. With respect to the current, average current. With respect to the voltage, it is the average voltage. Got my point? Means the same amount of charges to be transferred for the replacement of direct current, for the replacement of alternating current, for the same circuit, for the same instant of time. Then that current is called as average value. If it is a voltage, it is the average voltage. Okay, already you know that how to represent the average value. Okay, here I1, I2, IN. That is I1 plus I2 plus IN divided by N. I will get the average value of the current. Okay, that can be represented by 2Im divided by pi, which is equal to 0.637 into Im ampere. These equations also you remember because these are also be asked in the examination. Okay, for the definition point of view, write the definition along with these equation. I1, I2, IN are the what? Instantaneous value of the currents at the particular instant. N is the what? The number of the divisions. Then Im is the what? The maximum current. If you are considering I is equal to Im into sine of omega t. Okay, then the derivation. Okay, for the what? The alternating quantity or the sinusoidal varying quantity. Okay, the derivation for the average value of the sinusoidal varying alternating quantity. Listen this, if you are not getting, then you can ask. What we need to consider? We need to consider a alternating quantity. We need to consider the alternating quantity to identify or to determine the value of the average value, so that we are going to consider the sinusoidal varying quantity. With respect to that sinusoidal varying quantity, we need to consider the current equation I is equal to Im into sine of omega t. Okay, but omega t will be replaced by theta in order to reduce the solution method. Okay, then I need to consider instead of full cycle, I need to consider only the positive half cycle or the negative half cycle. Okay, which it is to be taken into a time of pi. Okay, the average value will be taken for only one of the half cycle. So that I average equal to 1 divided by pi, 0 to pi, I into d theta. There it is square in RMS value. Here only the I. That you have to remember. Don't get confused. To make the evaluation of the average value, then the RMS value. Okay, 1 divided by pi, 0 to pi, I into d theta. What is I in terms of theta? Im into sine theta into d theta. Okay, Im is the constant. I am taken that out. Im divided by pi. Integration of sine theta is what? Minus cos theta. 0 to pi. That is the maximum value and the minimum value. Then I average equal to Im into pi into minus, because I need to replace pi and 0, minus of cos pi, minus of minus cos, that is 0 it is, not the theta, 0. Okay, that is cos of pi is minus 1, cos of 0 is 1, minus into minus plus, minus into minus is plus, 1 plus 1, 1 plus 1 is 2, Im divided by pi. Okay, take your calculator, divide 2 by pi, how much value you will get? All of you having calculators with you now? 2 divided by pi, that value is equal to that of 0.637. I average is equal to 2Im divided by pi.